Here's a quick tutorial on your coin flip tutorial. Selecting this link will bring up this document here. Coin flip tutorial. So what we're going to be working with in this particular application is your random number generator to generate either a heads or tails and then track that. So the objectives, we're going to create an artificial artifact that uses randomness and simulates a model. We're going to create a simple model of a coin flipping, use a random number block to generate a random value in a specific range, define a global variable and assign it an initial value, and use a conditional statement, if, else, to evaluate a variable and follow an algorithm based on the value of that variable. Okay, we don't necessarily need to do this short experiment, but basis of it is that if you flipped a coin 20 times, would it come up heads or tails 10 times each, about 50-50%? Or is it going to be biased in one way or another? Did your count match your explanation based on your experiment? Could you conclude that your coin is fair or biased? I would probably say that it is fair, irregardless of the number that came out. It's probably just a matter of randomness. So the problem with this experiment of doing 20 times is you didn't perform enough trials to draw a conclusion about the hypothesis that this is a fair coin. So we're going to create a program that's going to allow us to flip a coin multiple times. Getting ready, import the CoinFlips project into your App Inventor site. So we're going to go to this site here, and it is going to download. Down here in the bottom left, you should see CoinFlip V1. It'll open up like this. We need to then import that into our App Inventor program and take a look at what they gave us. I have done that already. I imported my coin flip. I renamed it BSU. These labels may have looked like this in the beginning, a bunch of them, and all you need to do is right-click on those and expand those blocks. But this is what was provided in that base file. Oh, and in fact, let's look at the user interface a little bit. This is all was given. So we have some media in here of a heads and a tails picture. We have this button, we have our label set up, and we have ourselves an image. So this was all provided with that CoinFlip V1 download. Okay, so if we wanted to break down this application here, this is the working application that's already ready to go. But let's take a look at this. First, we need to let's take a look at this procedure that we have here, flip coin. We need to have a global variable called coin to hold the value of a 0 or 1, representing a heads or a tails. So this random integer will, every time this flip coin procedure is called, we will pick a number randomly between 0 and 1, assign that to global coin. This 0 will be replaced, or maybe not if it is that it is selected from a 0, but this is 0 is just to initialize a value for the variable coin. This 0 does not necessarily represent that it got that from this flip coin procedure. Let's go through this. If then else statement. If your global coin variable equals 1, then set coin image dot picture to heads, else set picture to tails. So the else statement is you don't need to have this condition set up, the if global coin is equal to 1, because there is only two choices. So if it is not 0, then inherently it will be 1. So the else statement only is requiring you to just change the picture to tails. You might see in your math drawer a random fraction block, but that is not what we will be using for this one. This randomly selects a real number between 0 and 1, not including 1. We are looking at a random integer block from 1 to maybe 100, and that would be inclusive. So that means that it could have a value of 1 all the way up to a value of 100 can be used. Your if-else statement, we talked a little bit about how that could work. And we use if-else statements in our life as well as in programming. It helps us set up conditions and program control. So for instance, here's an example. If we're playing Go Fish, if you have a card I ask for, then you give me your card, else you say Go Fish. The later would mean that the condition you have the card I asked for is false. That is, you don't have the card. that I asked for. If-else statements are all around us and they control the flow of things that we do, especially when we play games. So the way we want to work this is when our button 1 is clicked, that will be the button that flips the coin. So inside button 1, we will need to have this flip coin procedure in there. When button 1 is clicked, if global coin is 1, put the image to heads. Okay, so let's take a look at the application. Let's run it on our Android device, see what it does at this point in time. And I'm going to set that up now. Connect my Android device. Okay, so here is your base file CoinFlip v1. I haven't done anything to this. We have our image of a heads, we have a label of heads and tails, and we have a button that we flip. All right, first time through it was heads. Next time through is tails, and you can see that the image has changed. Tails again, heads this time, and we keep doing this over and over and over again. If we do it many, many, many times, hopefully we see a 50-50 result half the time. It's heads, half the time it's tails. So at 39 flips, we're about 50-50%. So again, when that flip button is clicked, I set my variable to a random integer between 0 and 1. If the selection is a 0, then we set our picture to heads, and we are going to set our label. We're going to set our global nums, which is another variable, num heads, and we're going to add 1 to that. That is going to be helpful when we calculate the value or the number of times that the heads part of the coin flipped up. So this here is joining your the text box, just heads, colon, to the value found in global heads right here. Same thing with false. If global coin is selected a only, it is not a 0. We go to the else statement, we change our picture to tails, and we increment our global num tails variable, which then goes into the text box down below. And then we call update labels at the end after the coin flips have been done to then update our labels. Good, so that's where we're at here. Now then, let's take a look at these enhancements. Modify your app so that heads or tails is spoken when the coin is flipped. Hint, use the text-to-speech component. Okay, so I have done that app here, that enhancement. The way we do that in your designer, we need to add in a text-to-speech feature. Under media, text-to-speech, drag that in as a non-visible component. In our blocks editor, I'm going to call my text-to-speech speech.speak, and I have a message that's going to say heads or tails. I'm going to place that where I find the value for heads or tails. So if global coins is 0, set my picture to heads, and I'm going to have it say heads at the end. If it is a 1, then we set the picture to tails. We're going to increment our tails label, and we're going to say tails. Let's test that. I may need to reset this. Okay, so let's see what happens here when I flip the coin. And it does report out a volume. It does report out heads or tails. Okay, so that adaptation works. Let's take a look at the next one. It says here, modify the app so that the user can shake the phone to flip the coin. Hint, use the accelerometer sensor. How would you avoid duplicating the code from the button clicked block for flipping the coin? Hint, use a procedure. Okay, so let's go in here to our designer. Under sensors, you should see an accelerometer sensor. Drag that in. It'll pop up down here at the bottom as a non-visible component. So we have access to it in our blocks editor here. So I did the code for this one here. Basically, what it said to do was to create a procedure so that I could then call it when it is shaken right here. So what I did is I created a flip coin procedure that all it did was mimic the flip coin button. So whatever is set here in your flip coin button, I'm going to put that in the procedure of flip coin. So all of this value here is going to go into flip coin except for your update labels. And the only thing that is different between this values and here is that I have added in my text to speech feature. So I'm going to add that in here and here. And now my flip coin procedure should do everything that's in this flip button. So what I need to do here to make it a little less cumbersome is, since I have developed this into a procedure, I'm going to call my flip coin procedure when I hit the flip button. I'm also going to update my labels with that procedure. I'm going to disable these blocks here. Oh, all of these maybe. That way they're not getting in the way. Oh my gosh. And I'm going to do the same thing with my accelerometer. When it's shaken, I'm going to call my flip coin procedure, which will do these things here, and then update labels. This way I'm not getting double clicking is different than my accelerometer, but they both do the flip coin procedure and update labels. So let's connect our emulator, our companion, and see how we have done. I might just be able to refresh that. Maybe not. Let's connect it. Nope. Okay, so here's our application. Let's see if it's working, FlipCoin. It looks like it's doing it. Now let's do the accelerometer. Okay, there goes tails. I was hoping it would pick up the tails with the shaking. Okay, so it looks like that works. All right, so let's just think, how can you accurately predict whether the next flip will be heads or tails? You can't any more accurately than flipping a real coin. If we have done that with our experiment, then we have successfully created what is called a pseudo-random number generator, or PRNG. And that is an important feature that we can use for a variety of things within computer science. So looking on to the remainder of this document here, we do have some reflections that need to be thought about. In your portfolio, create a new page called CoinFlip. So this is under your reflections in your portfolio. You need to answer these 3 questions. Write an if-else statement. Give several examples of if-else logic in your life. And then answer number 3, what enables us to simulate the coin flipping is in this app is App Inventor's random number block. This block constitutes a model of randomness, an abstract of real randomness, such as flipping a real coin. How might we use CoinFlip app to test whether this is a good model of randomness? And for your personal growth, you should try to look at these here if these links are active and good. There you go, CoinFlip tutorial.